Hi scholars, we're going to look at TEK 4.4b today. It says I can determine products of a number and 10 or 100 using properties of operations and place value understandings. So like an example would be 4 times 70, 4 times 700, anything with zeros in it, numbers that are multiples of 10. So let's get started. I want to start off by showing you these math problems. 4 times 7, 4 times 70, 4 times 700, and 4 times 7,000. Now we know 4 times 7 is 28. 4 times 70. Normally, my students will do this. Even after I teach this TEK, they somehow end up doing the longer way, which is 70 times 4. And so when they do 4 times 0, it's 0, and then 4 times 7 is 28. But what I want everyone to understand is that you could solve this as if the 0 doesn't exist. What I love about the number 0 is you can actually take it off and solve and then add it back on. So you can, however many zeros are in the question, you add it at the end. So like 4 times 700, you would do 700 times 4. 4 times 0 is 0, 4 times 0 is 0, 4 times 7 is 28. So if you look at it this way, you can pretend the zeros don't exist and do 4 times 7, which is 28, and then count how many zeros and add those at the end. So same thing here, 7,000 times 4, you would do 4 times 0, 4 times 0, 4 times 0, which is 0, 0, 0, and then 4 times 7 is 28. So why not, just look at it sideways and be like, well, there's 3 zeros in the question, so there's going to be 3 zeros in my answer. So let's look at another one. 8 times 3 is 24. So when you get 8 times 30, just think 8 times 3 is 24. There is 1 0 in my answer. There's going to be, or in my question, so there's going to be 1 0 in my answer. I always encourage my scholars to always underline however many here and here. I know it's an extra step, but with state testing and multiple choice questions, they're not just going to have 240 and then 3 random answers. They're going to have 240, 2,400, 24,000, answers with a difference between 1 or 2 zeros. And so if you're not careful in counting, you might pick the wrong one and then you get the answer incorrect. So 8 times 3 is 24. 2 zeros in the question, 2 zeros in my answer. 8 times 3 is 24, 3 zeros in my question, 3 zeros in my answer. Sorry. So, if you do it the long way, you're still going to get the same answer, but you're working too hard. You want to be aware that with the property of the property of 0 is you can always take it off and add it back on. You can only do it with zeros. So if you get something like 8 times 31, you can't knock off the 1 or knock off the 3. It only works with zeros. And that works also in division and also with simplifying fractions. Just a random example. If you have 10 and 100, you can actually, if there's a 0 here and here, you can knock those off and then get 1/10. 10 100ths simplifies to 1/10. Just a random example, but that just tells you, how really cool and fascinating it is with the property of being 0. I want you to try solving these. Press pause, solve them, and press play when you're ready to check. Okay, 9 times 4 is 36. So when I have one with an extra 0, that's going to be 360. When I have one with 2 zeros, it's going to be 3,600. When I have one with 3 zeros, it's going to be 36,000. Same thing, I want you to do these 4. Press pause, solve, and press play when you're ready to check. Okay, 7 times 6 is 42. So then 7 times 60 is 420. 7 times 600 is 4,200. 7 times 6,000 is 42,000. Remember to count your zeros very carefully. Let's look at this one. This is not the exception to the rule, but more like just be careful that you don't overlook something. So if I were to take off the zeros, it would be 8 times 5, which equals 40. And I noticed there are 2 zeros in my question, so there needs to be 2 zeros in my answer. But then it's like, wait a minute, there are 3 zeros in my answer. Well, you have to realize this 0 came from this multiplication problem. 8 times 5 is 40. So that 0 has, I guess every right to be there. And then these 2 zeros go here. So, just be careful that, like sometimes what I do is like I would write 40 and then underline the 2 zeros and put the 2 zeros there. Something that kind of helps sometimes is if you look at it logically, using number sense, if you're saying 8 times 500 and you're saying, well, there's 2 zeros in the question, there needs to be 2 zeros in my answer. 8 times 500 would not equal 400. When you multiply, your numbers are getting bigger. So 400 would not make sense. You would need a third 0 because this 40, again, came from 8 times 5, and then these 2 zeros came from the question. So if you're to look at this one, 6 times 5 is 30. That 30 came from this problem, and then there are 3 zeros, so then there are 3 zeros extra in my answer. So my answer is actually 30,000, not 3,000, because again, if you said 6 times 5,000 equals 3,000, your numbers should be getting bigger, and in this situation, if I said it was 3,000, then my answer is getting smaller, and that wouldn't make any sense. So I want you to do these 3, and then I put a challenge question in there, which is going to be the next concept that I'm going to teach. So press pause, solve, and press play when you're ready to check. Okay, so first part is 4 times 5 is 20. There are 2 zeros, so there will be 2 additional zeros in my answer. Remember, the 20 came from 4 times 5. 50 times 6, well, 5 times 6 is 30, and there is 1 0 in my question, so there will be an additional 0 in my answer. 80 times 4, 8 times 4 is 32. 1 0 in my question, 1 0 in my answer. Now, 12 times 40, it's actually very easy. Just knock off the 0. 12 times 4 is 48. Add 1 0. It's that easy. So with these kind of questions, like if you get 29 times 40, I really don't want you to do it this way. This method takes way too long when there's a 0 involved. Plus with putting the 0 down, if you think about it, it's 0, 0, 0 again. Like it's just too many zeros. It's easier to just eliminate the 0 and do 29 times 4, 116, and then add the 0 back on. So same thing, 16 times 3 is 48. Add the 0 back on. 200 times 73, do 73 times 2, taking off the zeros, is 146. Sorry with my handwriting. 2 zeros in my question, 2 zeros in my answer. I want you to do these 3. Press pause and then press play when you're ready to check. So what I did was I went ahead and solved the smaller math problem without the 0, and I'm just going to show you how to add the zeros on there. So 18 times 4 is 72, add 2 zeros. 78 times 6 is 468, add 2 zeros. 20 times 47, so 47 times 2 is 94, add 1 0. Now let's look at these. What's nice is, again, with the property of 0, you can take both zeros off and just do 8 times 3, which is 24, and then just be aware on both numbers that there's 2 zeros. So 2 times 6 is 12, 2 zeros. 7 times 3 is 21, 2 zeros. So let's look at a few more. 40 times 70. Knock off the zeros, it's 4 times 7, so 28. 2 zeros, so 2,800. 800 times 600. I want you to just think, if you did it the long way, how long that would take. That is so many zeros, that is so many steps. What's wonderful is you can take off all 4 zeros and just do 8 times 6, which is 48. 1, 2, 3, 4 zeros. 480,000. 2 times 3 is 6. 1, 2, 3, 3 zeros. I want you to do these 3 problems, press pause, and then press play when you're ready to check. Okay, 6 times 3 is 18. 1, 2, 3, 4 zeros. So my answer is 180,000. 70 times 400, 7 times 4 is 28. 1, 2, 3 zeros. 28,000 is my answer. 20 times 500, 5 times 2 is 10. Notice there's a 0 here that came from that problem. And then there's going to be 3 additional zeros from the question. Last 3 questions. Press pause and solve. Press play when you're ready to check. Alright, 900 times 300. 9 times 3 is 27. 4 zeros. 4 times 6 is 24. 2 zeros. 2 times 8 is 16. 3 zeros.